Physics has traditionally been viewed as a discipline of science concerned largely towards the research on matter. Physics may be used to solve a variety of real-world issues. A scientific method, which consists of several stages, may be utilized to address current physics dilemmas using experiments. Real-world applications using physics concepts involve architectural, spaceflight, and healthcare studies, just to name a few. My task is to describe physics seen while on travel across the United States. We went on a walk through a park where children were playing. At the center, there lay a lever that represented a seesaw. Several principles of force are used in that very same mechanical apparatus. Also, inside the park, there existed a slide that prompted children to trek up a series of steps prior to actually descending to the bottom. The slide depicts on the inclined plane as well as the methods of countering gravity to guarantee a nice journey while descending. We went to a car factory in Kansas City to investigate the applicability of Newton's law of motion. Cars have round tires enabling accelerate and smoother travel in accordance to the law of motion. Furthermore, we investigated the factors causing friction by analyzing the form of things, including vehicles, aircraft, to oppose the movement of air. Tsunamis and other mobility of fast-moving items are both being studied using sound waves as well as vibrations. Also, it is feasible to converse while simultaneously powering items using the principles like electricity, magnetism, and electromagnetism. Additionally, cranes employs velocity and energy efficiency ideas along with hydraulics to raise them utilizing minimal force. A scientific model is divided into stages that outline the method of recognizing an issue and offering an answer. This approach can sometimes be used in physics, particularly when conducting an experiment as well as demonstrating or disproving ideas. This method would contribute to the construction of foundation and producing answers to the different current physics challenges. For example, the method may be used to provide a framework for hypothesizing the existence of space-time notions. As an example, consider the following hypothesis. Space and time are mostly distinct. Classical physics is based on Sir Isaac Newton's concepts. According to the first rule in motion, an object at rest will remain in that position until acted upon by an outside force. A ball placed on a flat surface to show the basic idea just use an external force to cause the ball to travel. A law of energy conservation has been used in a variety of fields, including industry. Water, for one example, drives turbines inside a geothermal network to create energy. These turbines propel a generator that generates energy. I came upon a sluggish train while studying the principles of motion. I realized that this train generated a force that operated with one direction. Even so, according with the third law of motion, this train encountered other forces that pushed it in the opposite direction. In addition, after touring a construction zone, we saw the converting of kinetic energy becoming into mechanical energy by using a crane to destroy useless buildings. We saw the utilization of both motion and friction in the automobile production facility, such as usage of ball bearings, which can assist in the movement of big components between one place and another. Bernoulli's fluid dynamics is being used in the flying business to develop a dependable method of building a system for transporting passengers and commodities between one location to another. Also, the discovering on the capacity of transfer electrons between one area to another facilitate the development of complicated technologies including radios, TVs, and lighting systems in terms of the use of electricity. Additionally, X-ray technology makes use of a variety of physical properties including lighting and electromagnetism. In terms of advancement, quantum technology illustrates the universe's potential. The power of quantum computers is being speculated about. The NIST-Schrodel clock is an example of quantum technology. The clock that is shown possessed the ability to maintain time for more than 300 million years. That very same piece of technology is among the greatest modern innovations that make use of quantum technology principles. When traveling, one must always enjoy breakfast, and one might not think that we use physics while making toast. It is a very ubiquitous appliance throughout most houses, and many individuals would utilize it on a regular basis without blinking. Individuals are unaware that the brilliant red blazing thermal element is where quantum physics began. Within the late 1800s, scientists discovered that an item could resist getting heated to high degrees while emitting the very same red hue despite its composition. The quantum theory was proposed by Max Planck in 1900. In fixed amounts, distinct atoms and molecules may either produce or receive energy. Quantum energy is indeed the lowest quantity of energy which may be released or received in the shape of electromagnetic radiation. Here was where quantum science, now as a field of study, began.